Good question. There it is. There it is. Okay. So, our next talk in the mission and international participation section here, plenary session, is going to be given by Noah. Again, we get to hear from him 2 times in one morning, and his talk reminds me at the second, what we used to call Lunar Science Forum back in 2009. The big news was LRO, and we were all just so excited to get some data back, and so what Noah's going to be talking about is reflecting on the last 7 years and perhaps the next couple. So right. Noah, please go ahead.
Hi again. I'm going to talk about the Rolling Stones now. No. In all seriousness, I mean, so on this slide, basically the punchline is that we were just received word that we were extended for 2 more years. Death, taxes, controversy with the Olympics, and LRO are things that you can count on. LRO is nominal, which is our fancy way of saying that everything looks hunky-dory. I'm bringing up our heads-up display of where the spacecraft is right now, and this is your annual reminder that we are still orbiting the moon. We're currently 44.5 kilometers above the SPA, as a matter of fact. So how about that? It's in shadow, so no camera and no images, LROC images being taken right now, but we are in this quasi-stable elliptical orbit, which allows us to stay at the moon for 7 years. Our periapse takes us very close to the South Pole, and I'll talk more about that in a little bit. We've just made another delivery to the PDS. We're now well over 700 terabytes of data, the largest planetary science database of any mission in the PDS. Of course, I left it in my bag, but we have a volume 1 of the LRO special issue of Icarus is out, over 300 pages of awesome science. In October 8th is the International Observe the Moon Night event. We have Andrea Jones here who can certainly explain more about what that is, but we're very glad to see that continuing along with the mission. So we did this extended mission proposal, and I don't want to get into too much of the, we not talk about the extended mission proposal at all. But basically we did it, we couldn't go to a new target, we couldn't leave the moon, and we didn't want to leave the moon, but we did want to basically challenge ourselves to kind of reformulate the mission. And so we took a very proactive posture with the senior review, perhaps starting the process, well, earlier than some would have liked, but the end result was well worth it. We wanted to propose a mission, an extended mission that presented all 7 instruments. So that's one of the big outcomes of the mission, of the proposal, is the return of Mini-RF to operational status. We wanted to take advantage of our orbit and our long-lived orbit. And I have a plot up here of mission duration of orbital missions at the moon over history, and you'll basically see that apart from Explorer 35, which was sort of not what you would typically consider a planetary science mission, LRO has been at the moon, orbiting the moon, the longest of any NASA or international lunar mission in history. And that puts us in a very unique position to make unique measurements. Every measurement we make is by some way new, even though it's the same style of measurement. We're observing the moon now with an extended baseline, which allows us to characterize the moon in a totally unique way, similar to how we've been measuring Mars and looking for changes on Mars. You think of our Earth monitoring satellite. Just because you have a satellite that's orbited the Earth for a year doesn't mean we've answered all the questions about the Earth. You need to look for changes, and that's really what we're doing at the moon. We call ourselves this next extended mission the Cornerstone Mission. I'll explain a little more about that in a little bit. But we feature new instrument modes, basically creative ways to use the instruments in new ways. As I said before, we returned Mini-RF to operational status with some new tweaks. And we were looking at the moon in 3 different eras of lunar history. And I'll talk more about that as well in a moment. We have several highlights of the proposal that were called out by the review panel. One that we've, as I talked about 30 minutes ago, early career scientists have an active role in leadership of the mission. In addition to my role as deputy project scientist, We brought on several new COIs, team members, as well as promoted early career scientists into mission leadership roles. Brett Nevy is the deputy PI for LROC, Wes Patterson, now the PI of Mini-RF. As a side note, knowing Wes as well as I do, having been his roommate in grad school, I still can't imagine seeing my peers rise through the ranks like that. Lynn Carter, deputy PI for Mini-RF, Kathy Mant, the project scientist for LAMP. As I said, many COIs and collaborators have been brought onto the teams. One other highlight from the proposal is our productivity. This is a chart that actually the previously mentioned William Ostrak put together of publications by the LRO team over time and publications by non-LRO team members over time. And we're very proud of the fact that the community has embraced LRO data in the way that they have, publishing more papers now than the LRO team has over the last 7 years. And that's a real testament to teams for putting out usable data. So this new orbit, the orbit that we're in, allows new measurements. And I've always shown this chart, and I'm sure people have grown tired of it, but it's really important because it shows the evolution of the mission. This top plot is a history of our orbital elements, our periapsis and apoapsis. And you can see for the main science mission from 2010 to 2011, we were in our roughly 50-kilometer circular orbit. That was an awesome orbit because we were so low over much of the moon, but it required an enormous amount of fuel. In 2012, or just before 2012, we went into our quasi-stable orbit with a high periapsis over the North Pole and a low periapsis over the South Pole. Early in 2015, we actually lowered the periapsis, taking us within, and sometimes 20 kilometers over the lunar South Polar region. Now, I mentioned the South Pole, but we're actually drifting away from the South Pole with time, that we're not actually passing over the South Pole. We are now about 4.5 degrees away from the South Pole and slowly drifting away over time. Now we use that to our advantage, and you'll see how that works out in a moment. We conserve our fuel to use it to, one, unload momentum, also put ourselves in an optimal spacecraft configuration to view special events, whether that's a lunar eclipse, or if there's ever a landing that occurs on the moon, or an impact of spacecraft, we can try to observe that. So we've taken a very proactive stance at conserving our fuel, not for any other reason than just to be able to maximize science opportunities when they come along. I mentioned before, we focused in the proposal on our 3 eras. One, looking at contemporary processes, and this is actually, I think, really important because it's these contemporary processes, things that are happening on the moon today that LRO is uniquely qualified to, or situated to observe. I like to think that if you wanted to make these measurements, you'd have to send a mission to the moon, make 6 years worth of measurements, and then you could start. Because we have this extended baseline, we can look at things like volatile distribution on short time scale, or on extended time scales. LROC is able to identify new impact craters that have formed in the time that LRO has been at the moon, and also look at changes that are occurring in the lunar exosphere. We also, of course, are looking at processes that have occurred over longer geologic time periods, whether it's a regolith breakdown over billions of years, or early events that have happened billions of years in the past. And so we proposed a mission, the Cornerstone Mission, that try to look at all 3. This is our menu, our placemat menu, looking at new measurement modes for each of the instruments, as well as how those instrument modes factor into our science questions. For the purposes of this presentation, I'm going to focus on 3 of the new modes and look at how they contribute to our understanding of the volatile cycle that Dana so eloquently talked about earlier on. So we take this synergistic approach, and if you've read the panel review, they want more of this synergy, and so we are really going to highlight that in the Cornerstone Mission and in our planning for the next extended mission, which I know Jeff is going to like hearing this, that we're already making plans for as we speak. So we look at these sort of 3 primary themes: volatiles, impacts, and regolith evolution, and volcanism and internal processes. In focusing on the volatile processes, each of the 7 instruments are contributing something important in our understanding of both the temporal variability, also the depth profile of volatiles across the entire lunar surface. 3 of the instruments, or 4 of the instruments, are making new measurements, new styles of measurements that I'll talk about here, but particularly LAMP, Crater, LROC, and Mini-RF are all contributing significantly to our understanding of volatile processes. So first and foremost, I want to talk about LAMP, because this is kind of, I don't know, is one of the sort of the big changes that's coming to the mission. Very rarely in my experience anyway, certainly with LRO, do we make, we can't go to the spacecraft and change something. If we could, we'd fix mini-RF again. We'd do other things, but actually, LAMP is going to open up something called their fail-safe door. Now, this probably sounds a little bit more harrowing than it should, but basically, as a backup option for the small pinhole that allows reflected solar energy to come through to the detector, we're going to open this fail-safe door, which should increase the throughput of signal, basically allowing us to make daytime measurements of the surface. That's essentially a new type of measurement for LAMP. This is going to happen at the beginning of the Cornerstone mission in early October. It's a one-time event. It's going to increase our throughput for about 10% for the LAMP signal, and once the door is open, it's open for good. So this is an irreversible change, so it's not something we make lightly, and the LAMP team has been studying this process very thoroughly, and we're excited for this opportunity. Basically, this is just a visualization of what that kind of means. We'll increase the count rate for the LAMP instrument, and really make some pretty important measurements of the diurnal variability of surface hydration. Mini-RF, it's the zombie instrument. It's back from the dead. After its 2-year hiatus, we were approved to turn it back on, and Wes and his team actually came up with some novel new measurements using both S-band and X-band measurements. So in years past, as you may be aware, Mini-RF, the transmitter experienced a failure in December of 2010, so it was no longer able to actively transmit. We instead used Arecibo as a transmitter to measure the reflected signal from Arecibo back off to Mini-RF. That was a very successful experiment that's now highlighted in a paper by Patterson et al. But they also recognize that perhaps we can use a different satellite, and so we're going to, or a telescope, and so we're going to be using the Goldstone antenna. This is a result about possible buried ice in the Cabeus crater that basically highlights the utility of these bistatic measurements. When we use Goldstone, it'll increase the coverage that we can get over both the South and North Pole. Because Goldstone is pointable, it gives us some flexibility. There were several periods of time where we couldn't use Arecibo because of, in addition to scheduling issues, you can't point the side of the mountain that Arecibo is built into, so we just couldn't use it. Goldstone offers additional flexibility at X-band wavelengths. So we're really excited about this new mode of operations for Mini-RF. They brought on new team members. As I mentioned before, Lynn Carter is now the deputy PI for the instrument, and so we've really given that instrument a total refresh. Here's an example of a measurement they made in April, as sort of an example of what they can do. The blue areas in here are areas of the South Pole where they can make measurements. And so if I were to show you the Arecibo coverage map, it would be much more limited than this. And so we're very excited by the opportunity to make additional targeted measurements with Mini-RF. So welcome back. Crater. The Crater instrument, which is one that I know that maybe some of our geology friends here have, at least I know I have a difficult time half the time understanding exactly what Crater does, as Harlan can attest to. But the Crater team was presented with a real challenge in this last extended mission. Crater was added, or as a part of LRO, as a radiation detector, and so much of their science focuses on the radiation environment, but we really wanted them to focus on the planetary science measurements, what's happening at the lunar surface. And I mean, I give the folks off the Crater an incredible amount of thanks, because they came back and essentially devised totally new style of measurements to look at surface hydration and subsurface hydration within the upper 10 centimeters of the lunar surface. And so they've developed a new off-nadir viewing mode where basically they can look at protons that are forward scattered off of the surface, and that gives a sense of the depth distribution of volatiles. They've done many tests. I'm always interested when I hear from the Crater team that they've gone to Mass General Hospital to use their proton devices on the weekends to make measurements. And so they've really come up with a brand new style of measurement to probe subsurface volatiles. And lastly, I mentioned before the sort of the breathing of the orbit away from the poles. So this is the south pole of the moon out to about 82 degrees south. Here is Shackleton Crater. And this Eye of Sauron here is basically a density map of where more observations will be made. So basically, if you imagine the spinning ball of yarn orbiting the moon, when we were in a perfectly circular orbit over the South Pole, we were passing over near Shackleton every orbit. Now that's widened out, and so with every sort of expansion of the orbit away from the South Pole, our density of measurements in the immediate vicinity of the South Pole is increasing. And this sort of improves the measurement signal for our integrating instruments, LEND, LAMP, early on LOLA as well. So it's a very important sort of feature of our orbit that we get a denser measurement in areas. Eventually within the next extended mission, if we're so lucky to have one, we'll have an increased measurement over Cabeus as well, and that's sort of just over the northern rim of Faustini and several other areas of permanent shadow. So we're really very, very fortunate that we can sort of leverage these long duration measurements as we've been at the moon for 7 years. So we officially begin this Cornerstone mission October 1st. That's when LAMP will open the barn doors, as it were, and we'll begin this new mode. But ultimately, it's not quite business as usual, but we are very excited for the opportunity to continue at constant funding levels, which is really, really a benefit to the science teams. We're going to be holding LRO data events again at LPSC next year and as other events in the future, in particular possibly at the League meeting. As I said before, planning for the next senior review is underway. We take the feedback that we got from the senior review panel as sort of a roadmap to writing the next senior review proposal, so that has started. And just as a reminder, we have this unique asset at the moon. Let's not take that for granted, and please keep using the data, publishing with the data. That helps the mission, that helps all of us justify our long-term existence. And so with that, I'll stop and take time for questions. Thank you.
Time for one or two questions for Noah on LRO. Very quiet audience today. So, okay, we'll move on. Thank you very much. Yeah.